Picture this: 90 million rows sitting in a database across 48 tables. You type one plain English sentence. 30 seconds later, a finished dashboard is looking back at you. And this is it. Not a mock-up and not a demo reel. 6 coordinated charts built from one typed question and rendered natively in React with 3 open source libraries. We will come back to every piece of it. Here is the roadmap: the analyst bottleneck, the journey of one question through the pipeline, how the SQL earns 100%, how 6 cards get planned, how they render natively in React, and how 3 NPM packages replaced a whole BI server. Section 1. The analyst bottleneck, or why good questions go unasked. Because to understand why any of this matters, you first have to feel the pain of a normal enterprise database. A sales manager wants to know which customers are most profitable. Today, that means filing a ticket, waiting 2 to 3 days for an analyst, and hoping the query comes back right on the first try. And the analyst is not being slow. This is Wide World Importers, a production-scale database, and it is genuinely hard. 48 tables, 561 columns, 98 foreign keys. Even an experienced developer needs 10 to 20 minutes to write one correct join. Now flip it. You type the question in plain English, and under 30 seconds later, 6 coordinated charts. No ticket, no SQL, no waiting on anyone's calendar. That gap between a 2 to 3 day wait and a 30-second answer is the whole story of this system. So let us open the machine and follow one question all the way through it. Section 2. The pipeline. The journey of one question. Say you ask for the top 10 customers by profit margin. 5 stages stand between that sentence and your dashboard. And here is the actual pipeline, straight from the project. The question enters on the left, the dashboard comes out the right. In between sits schema retrieval, card planning, SQL generation with validation, and native chart rendering. Stage 1 is schema retrieval. Out of 561 columns, where should this question even look? A vector database called Qdrant acts as a semantic search engine, mapping your everyday business words to the right database views. The matching is layered. Common words go by simple keyword, so revenue points straight at the sales summary view. Unusual phrasing falls through to semantic search, which reads meaning instead of spelling and keeps only the strong matches. Stage 2 is the planner. Claude Sonnet 4.6 reads that schema context and designs exactly 6 visualization cards, each one a different way of answering your question. More on that in Section 4. Then Stage 3 writes the SQL, 1 query per card. And critically, every single query is validated and tested against the live database before anything renders. The finished cards then render natively in React with no BI platform in the loop. End to end, that whole journey takes under 30 seconds. And along the way, it creates no tables, runs no migrations, and changes nothing in your database. Hold that thought, because it becomes Section 6. Section 3. Perfect SQL accuracy. And yes, we need to talk about the elephant in the room. AI models hallucinate, and database queries are exactly where hallucinations get expensive. Our first prototype wrote SQL that looked perfect, and then crashed against the real database. A column spelled slightly wrong, a date function from the wrong dialect. Generate and hope failed roughly 1 query in 3. So how does this system claim 100%? Not with one clever trick, with 3 stacked layers. And this figure, straight from the project, shows all 3 of them. Layer 1 is prevention. 14 strict TSQL rules go straight into Claude's prompt. Things like no order by inside a subquery without top. Never mix top with offset and fetch. Rules of the road. before a single line is written. Layer 2 runs after the model and before the database. 7 automatic post-processing fixes that rewrite the model's repeat mistakes. Stripping markdown fences. Injecting a missing over clause. Cheap, deterministic, and invisible. And layer 3 is the safety net. If a query still fails against the live database, the exact error message feeds back into the next attempt, up to 3 tries. The user never sees any of this. No stack traces, no broken cards. Now, here's the part that sounds made up. Once the first 2 layers were tuned against real failures, the retry layer stopped firing. In current testing, it simply never runs. And that is the whole philosophy. Build the cheap layers so well that the expensive layer becomes a net you hope never catches anything. The result is 100% SQL success across more than 10 categories of questions. There is one more gate before any query runs. 7 security checks. Every query must start with select or with. Anything that writes, deletes, or drops is rejected, flat out. System tables blocked. Injection patterns caught. Read only. Every single time. And if you still do not trust it, good. You should not trust any tool that hands you a number and hides how it got there. Every generated query sits right in the interface, expandable and copyable. Take it, run it in your own tools, and check the number yourself. Section 4. Planning the 6 cards, from raw data to a visual story. Because reliable SQL is only half the job, a good dashboard is not a pile of numbers, it is a coordinated set of answers. The planner selects from 12 distinct chart types: tables, bars, rows, lines, areas, donuts, scatters, funnels, waterfalls, combo charts, geographic maps, and more. It reads the intent of your question and the shape of the data, then composes the mix. And there are rules. All 6 cards must be different types. If the planner returns 2 bar charts, a validator swaps the duplicate for an unused type. And card 1 is always a data table, holding the direct answer to your question. I love this detail. The map card only appears when the question targets a specific subset of customers. So no more useless zoomed-out world map stapled onto a salesperson query just to look busy. So here is the finished product for top 10 customers with the highest profit margin. 6 cards, 1 story, and every one of them came out of the pipeline you just watched. Card 1, the sortable AG grid table with the direct answer. Then a horizontal bar chart ranking the margins. Then a dual-axis combo chart, revenue against profit. Then a scatter plot correlating revenue and profit. A donut breaking down the customer category mix. And a leaflet pin map of exactly those top customers across the country. 6 angles on 1 question. And here is the thing. None of these is a picture, and none of them is an iframe. Every single chart is a native React component rendered right in the page, which brings us to Section 5. Section 5, rendered natively in React. Because the AI plans the dashboard, but the rendering layer is where the first version and the second version completely part ways. Every chart you just saw is drawn by 3 open-source libraries running right inside the app. ECharts renders the bars, lines, donuts, and scatters. A G-grid renders the sortable table, and Leaflet renders the map. No iframe, no embed, no BI server in the middle. And because every chart is a first-class React component, we control all of it. The colors, the tooltips, the axis labels, the way it reflows on a phone. Nothing is trapped behind someone else's SDK. Here is a detail I love. ECharts has no built-in waterfall chart, so we build one out of stacked bars, an invisible base column holding each floating segment at the right height, positive values green, negative values red. It looks like a waterfall because underneath it is just 2 bar series and some math. And it is not a one-query toy. Here is the Save and Load drawer. 25 saved dashboards, organized by category. Customers, sales and revenue, salesperson performance, products, geographic. Saved dashboards store the recipe, not the rows. Load one, and it reruns the queries against the live database. So the dashboard a manager saved last quarter shows this quarter's numbers today. Speed comes from a 3-tier Redis cache. Finished dashboards for a day. Query templates for a day. Raw results for an hour. Ask the same question twice, and the second answer skips the AI entirely and comes back in under 5 seconds with fresh data. Section 6. 3 packages, not a whole server. Because we actually built this twice, and the second build is the reason this video exists. The first version rendered these same dashboards with Metabase, a Java-based BI platform. It worked, but the deployment story hurt. Metabase needed Java 21. The download was 493 megabytes. It shipped with 17 database drivers, most of them unused. And its SDK pinned us to specific versions of React and Vite with no upgrade path. And it rendered inside an iframe-like container we could never quite control. So we deleted all of it and replaced it with 3 NPM packages and 10 small chart mapper files. That is the whole trade. 1 fewer service to run, 2 now instead of 4. No Java runtime, no API keys for the visualization layer, and total control over how every chart looks and behaves. The BI platform was not bad. It was just heavier than what it bought us. And underneath, the safety story is unchanged. The whole system sits beside your stack as an independent service, and it talks to your database through a strictly read-only connection. It never touches your base tables. Every query goes through database views prefixed with _v. The views are the front door and the only door. Point it at a different database, create the views you want queryable, and the same pipeline adapts. Your database does not even know it exists. Which brings us to the line that reframes this whole project. The ROI of natural language dashboards is not measured in analyst hours saved. It is measured in questions that were never asked because the friction was too high. Think about that for a second. Every organization has hundreds of questions sitting in the gap between curiosity and capability. Remove the weight, remove the SQL, remove the friction, and you change what people even bother to ask. This system was built to bolt onto your data and to drop straight into your React app. So if your team keeps asking a database questions and keeps waiting days for the answers, message me. This is exactly the pipeline I build for clients. And here is the question I will leave you with. How many unasked questions are sitting in your database right now, just waiting for the friction to disappear?